So let us proceed and start on a Millman's theorem. This is another theorem. So as it is, the first thing is to state what the theorem says. So it states that parallel current sources can be replaced by a single current source. So from there we deal with we see the procedure. There we did the procedure. So the procedure number one is convert all the voltage sources into current source. Procedure number two, procedure number two is replace all connected parallel sources by a single equivalent current source. Replace all the parallel current sources by equivalent current source. Procedure number three, draw the equivalent circuit. Draw the equivalent circuit. Do the equivalent circuit current source. Current source, all the resistance and the load being connected in parallel. All the resistances and the load being connected in parallel. And the last point is solve the equivalent current circuit for the desired results. Solve the equivalent current circuit for the desired results. So from there we just have to deal with an example. So example. So this is an example of the question, and the question reads, determine the equivalent current source with respect to XY terminals. Determine the equivalent current source with respect to XY terminals. So that's how simple the diagram is. So when you look at this diagram, you have only current sources, and there's a unique feature about the diagram. So the direction of current had been shown. So for us to determine the equivalent current source in the direction, and the direction the current is going to be flowing, we must look at the sum of the direction of the currents and their sum. So equivalent current source what I refer to as I equivalent, you'll have 0.2 amps. The direction is facing is up, plus 0. There's a current source here we have not indicated, which is 0.15. Here is 0.15 amps plus 0.15 amps. The direction is facing down, plus 0.5 amps, the direction facing up. When you look at this expression, the currents have been shown the direction. Whatever happens, that if they are positive, you're going to subtract. If they are going in the same direction, I'm going to add them. So in this case, the I equivalent is supposed to be 0.2 plus 0.5 is 0.7. So 0.7 minus that is 0.55. Shall be 0.55 amps, and the direction is going to be facing is up. So from there, we're supposed to, when you look at that, is 0.5 plus 0.2 is 0.7 minus 0.15 is 0.55. When you look at that, then we're going to determine the equivalent resistance of the circuit. The equivalent resistance, R equivalent. The resistors are in parallel. In this case, we shall have 1 over R1 plus 1 over R2 plus 1 over R3. We shall have whatever follows 1 over 600 plus 1 over 100 plus 1 over 600. So the LCM is 600. This is 1 plus 6 plus 1. We shall have R equivalent be equals to 600 over 8. So that this is 75 ohms. So when drawing this, you can draw this as a current source or a voltage source. Drawing the equivalent current source with respect to terminal XY. We shall have our current equivalent is facing up, and they shall have a resistance here. So this will be 75 ohms, and this will be 0.55 amps. So this is X and Y. That's the equivalent current source. So if you are also asked to draw the equivalent voltage source, drawing the equivalent voltage source. V is supposed to be IR and shall have I supposed to be 0.55 ohms times the resistance is 75 ohms. We shall have that, we shall have our values being given us 0.55 times 75. This becomes 41.25 volts. When drawing that, we know the voltage is facing up. We connect the resistor in series, so this becomes 75 ohms. This becomes 41.25 volts, and this becomes our X and Y. So that's example ends there, and it's very easy. There's something you recognize there is that when you're drawing the equivalent current source, the resistance is shunted, and when drawing the equivalent voltage source, the resistor is connected in series with respect to the terminals that we are being asked. So we're going to do another example. So we're going to do another example, and this example, this time we have with the voltage sources. The voltage sources, anytime you're converting them into current sources, you shall have the current source, and the direction must be determined. You must know the direction. So let us assume or actually indicate the values of current, like we shall have the I1, we shall have the I2, and this direction we shall have the I3. So that when determines the I's, then we connect the circuits as required. So determine the current sources. Determining the current sources. I1 is supposed to be V over R, which is supposed to be 36 over 18 K times 10 power 3. This is supposed to be 2 milliamps. Then I2, the direction is up. You get the direction of current alongside the value. The direction of I2 is supposed to be V over R. This is V2 over R2. This is V1 over R1. Then we shall have 27 over R2 is 9 times 10 power 3. We shall have this as 3 milliamps, also facing up. The direction of I3, we shall have V3 over R3. We shall have V3 is 6 volts. The R3 is 3 times 10 power 3. We shall have as 2 milliamps, but the direction is facing down. So from here, we determine the equivalent current sources. We draw the equivalent current circuit. Draw the equivalent current source circuit. We shall have that facing up. Anytime you are drawing the equivalent current sources, the resistors must be shunted, and you shall have the resistor shunted here. This is 18K, and this was 2 milliamps. This also 3 milliamps. This is supposed to be 9K. Then you shall have this facing down. This 2 milliamps. And the resistor we shall have here is 6K. And we have our 1 kilo ohm resistor. And this is the point of X, Y. So for me, in this case, we're going to determine the equivalent current source. Then I equivalent is supposed to be 2 milliamps facing up plus 3 milliamps facing up plus 2 milliamp facing down. So in this case, we shall have 3 milliamps facing up as our results of I equivalent. We determine the equivalent resistance. Determine the equivalent. Resistance R equivalent. Then that one, in the case we have with the two resistors in parallel, 1 over R1 plus 1 over R2 plus 1 over R3. It's supposed to be 1 over R1 is 18K plus 1 over R2, this is K. 1 over R2 is supposed to be 9K plus 1 over R3 is supposed to be 6K. The LCM here is 8, it's 18. This is 1 plus 2 plus 3. And this is supposed to give us 6 over 18. It's supposed to be 18 over 3K. This is supposed to be 6K as the equivalent value. Then from there, we are supposed now to draw the equivalent voltage source. Draw the equivalent current source first. So we shall have this facing up. This is 3 milliamps. Then we shall have the resistor here as the equivalent resistors as 6K. And we shall have our 100 kilo ohm resistors 1K. And this is XY. If you're going to draw the equivalent voltage source, draw the equivalent voltage source. V is supposed to be IR. I is given as 3 milliamps times 10 power minus 3 times 6 times 10 power 3. So this and this cancel, we shall have 18 volts. We draw the equivalent voltage source. This is 6K, this is 18 volts. We shall have our resistor here as 1K. So in either case, you can determine the current through the resistor. So current is supposed to be voltage over resistance. It's supposed to be voltage is 18 volts over 6 plus 1, which is 18 divided by 7. This 7 is in terms of kilo ohms. So 18 divided by 7 is 2.57 amps. So this is the answer with the voltage source. But you can also look at it from the current equivalent source. So from the current equivalent circuit, the current through the 1 kilo ohm resistor the 1 kilo ohm resistor will be I 1 kilo ohm. Maybe the opposite arm is 6 kilo ohm over 6 plus 1 multiplied by 3 milliamps. So this this milliamps. We divide that, we shall have 6/7 times 3. It's 2.57 also. This 2.571 milliamps. So equally, when you use both cases, you are able to get at the same value, the same answer. So it doesn't matter which current source or voltage source or the type of circuit you are using, but both cases we are able to arrive at the same point, at the same answer. So this is generally about the Millman's theorem. So you take some key note concerning the Millman's theorem. Number one is that you must be able to convert all the voltage sources into current sources, then determine the equivalent current source, then determine the equivalent resistance, then draw the circuits as a current source or a voltage source, and determine the current through the load or through the network that is required. That's the end of Millman's theorem. So we shall be able to meet for the next lesson. We shall be doing the maximum power transfer.